Hello, I'm Charlie Gates.
Hello, and I'm Hannah Ernst, and today we'll be showing you our breathalyzer.
You heard that right. It is the breathalyzer experiment. We'll be showing you the chemical reactions that occur inside the police breathalyzers.
To get started, we will need the breathalyzer solution, which we have here. We prepared this by dissolving 6.25 grams of potassium dichromate into 125 milliliters of water. After this was all dissolved, 125 milliliters of concentrated sulfuric acid was added to the solution. This solution is added in an ice bath because the reaction becomes very corrosive and hot, so we wanted to keep it cool. Then we added silver nitrate, creating the final breathalyzer solution.
We will be using acetone, methanol, isopropyl alcohol, and for real-world relation we'll be testing the reaction of alcoholic beverages such as beer, wine, and whiskey to show how these alcoholic beverages will react with the breathalyzer solution. When conducting this experiment, it is very important that you are wearing your protective gear, like me and Hannah are, with our gloves, our goggles, and our beautiful aprons.
We have dispensed our breathalyzer solution into test tubes. When the solutions are added to the breathalyzer, they will change to a dark green color if alcohol is present, and the faster it changes, the higher the alcohol content. The original solution, dichromate, will react with ethanol, creating chromium ion, the blue-green substance, and acetate and acetic acid when it is clear.
Which is clear. Okay, so now I will be adding the methanol to the breathalyzer solution. As you see, when the methanol is added, it becomes a dark green because it reacted very fastly. It very quickly became the dark green, and you can see the acid that is developed is actually sitting on top of the solution.
Now I'm going to add the isopropyl alcohol. You can also see that this reacted very quickly and changed colors right away.
I will be adding the acetone to our breathalyzer solution. The acetone is reacting very slowly. I mean, it's still very orange, but if you were up here right close, you can see that it's slowly turning to a darker green, and there's some reaction going on top of it. This will take a much longer time to react because there's a lower level of alcohol in that solution.
As mentioned before, this is often applied on police forces. Drinking and driving is very dangerous for all involved, as well as to innocent bystanders. When officers have suspicion of someone driving under the influence, they can request to blow on the breathalyzer to assess their blood alcohol content level.
Using a police breathalyzer is a quick and easy way for law enforcement to assess the blood alcohol content. This experiment represents the reaction that occurs inside a police breathalyzer, and through electronics and stuff, they're able to tell the different colors and different levels of how fast it changed to determine the blood alcohol content of the person.
To grasp the real-life application, we will now add a few different alcoholic beverages to our solution.
Okay, this is a sample of Miller Lite beer, which is 5.5% alcohol. Okay, as you can see, it did react decently fast because there is alcohol present, and it's not as dark of a color as some of the other ones. Came out as more of a lighter blue, and it will get darker as time as the alcohol gets to sit in the solution.
Now we have a sample of Arbor Mist Moscato. It has 6% alcohol content. Notice that rate at which this solution changes. Again, it changed rather quickly, but isn't as dark as some of the other things with a higher alcohol content, but clearly alcohol is present.
Okay, finally we have our sample of whiskey. It's 80 proof, which means it's 40% alcohol. Compared to the beer and wine, this should react much faster and should be a much darker color. As you see here, a very dark color, as the whiskey was able to react much faster because the level of alcohol is much higher.
We would like to thank you for tuning in for our presentation and wish you all a wonderful day.
These here are our wonderful sources.